Again, I've got my three situations. I know that the velocity should always point tangent to the curve. I know what the speed is in each case. I'm going to go ahead and draw these vectors. Here is the first case. Here is the second case. And really, this is just a bigger triangle, if you take a look at it, right? A and C are at the same points as A and B were. So all the triangle legs have just doubled here. On the other hand, in case 3, the triangle's not the same because I'm able to move farther around the circle because I have the same speed, but I have moved through a greater angle, right? So the triangle kind of opens up in that case. And I'm going to use those 3 pictures to try to figure out what's going on with the acceleration here. So I've got a nice baseline, right? Delta V over delta T for A1. For A2, I noticed that the change in velocity is twice as big here, but the change in time is half as big because I've gone the same distance around the circle, but I'm moving faster, so it's going to take me less time. If I combine those, I see that my acceleration is actually going to be 4 times bigger, even though the velocity was only twice as big. That's pretty neat. On the other hand, if I move over to case 3, we see that the change in velocity is about twice as big. That's something that will hold as long as the angle of the velocity vectors is small, which it is as long as we're taking the limit. But delta t here, as we said, is the same. So we've got the same change in time in this situation as in the first one, which means that the acceleration is only going to be twice as big. So even though there's a change in both case 2 and case 3, we end up getting different impacts from those changes. Which might let us conclude, especially if we took some more examples and really built up a broad set of situations, will let us say that the centripetal acceleration actually goes like the square of the velocity divided by the radius of the circle, right? So the more speed you've got, the more centripetal acceleration you're going to have, and the smaller the radius of the circle that you're going around, the bigger the acceleration you are going to have.